My name is Suzette Person. I'm the Director of Software Engineering here at UNL, and I'm also an Associate Professor of Practice in the department. I worked as a software engineer for almost 20 years in industry, and most recently worked at NASA as a research computer scientist. Software engineering is a discipline that has grown out of originally mathematics and then computer science, and it's become a discipline in its own right. So in the early days of computing, software could be written by an individual or a small number of individuals, and it was relatively easy to build it and maintain it. But the software that we have today is much bigger, and it's much more complex, and it's written by many individuals. Sometimes those individuals aren't even a part of your organization. So this means we have to have discipline processes, we have to have techniques for pulling all of these pieces together. And so software engineering is that discipline of being able to design software, to build it, to test it, to maintain it, to make sure it works reliably, to make sure it's safe, to make sure it's secure, and it meets the demands or the needs of the client. It's important because computing is so much a part of our lives today. Almost everything we do involves a computer. So whether it's the computers we carry around in our pockets that we call phones, those are really small computers, the computers in the hospital for the medical devices, computers in our car. So every aspect of our life depends on computers, which are driven by software. And so being able to build software that works reliably, it works correctly, it's safe and secure, requires these engineering processes to make sure it works. Software engineering is very similar to computer science. We study many of the same topics, but in software engineering we have more focus on the engineering aspects of software. How do we design it? How do we architect it? How do we test it? How do we make sure it works correctly? In computer science, we're focused on algorithms, we're focused on data structures, we're focused on things like artificial intelligence algorithms, we're focused on machine learning, informatics. Software engineers take what computer scientists have learned and what they've discovered, and we apply it to real-world problems. Computer engineers, on the other hand, are focused on both software and hardware. So they look at the system as an entire unit and how it works together. So computer engineers have this hardware component that relies on having knowledge of electrical components and electronics. Our new software engineering program at UNL is a program that integrates computer science and software engineering topics from the very beginning. So software engineering students start with the software engineering core, which is 4 courses, and we teach software engineering and computer science at the same time. What we've done in our program is we've developed a curriculum that helps students understand what software engineering is from the very beginning. And they get a chance to practice software engineering techniques from the beginning, and they learn what it really means to engineer software. After they complete the core, they take more in-depth software engineering courses. So they learn more about how we design software, how do we architect the software, how do we test it. They learn requirements engineering, how do we take specifications from the end user and translate those into software. They also do a 2-year capstone. So they spend 2 years working on real-world projects with industry sponsors. Students from the software engineering program are well prepared to go out into industry because they've been practicing software engineering the whole time they've been in the program. So when they leave UNL, they've already been doing the kinds of things that they're going to do once they get into an internship or once they get into their jobs. We have software engineering faculty at UNL who are ranked in the top 3 in research in the world. And these are the faculty that the students will be learning from. And not only are these faculty highly ranked when it comes to research, but they've also worked in industry. So they know the real challenges of software engineering. They've been out there. They know what it takes to be a good software engineer. Because computers are a part of nearly every aspect of those 14 challenges, any of those challenges could be a place for a software engineer to contribute. So all of those systems that are being used to solve those challenges require computers, they require software, and so the software itself is going to be complex enough that it needs to be engineered. It's not software that an individual is going to write and solve the technical challenge. It's software that many people are going to contribute to. And anytime you have a large number of people working on software, you need to have software engineering techniques in place. You need to have that infrastructure in place. So that's what's really exciting and what's really cool about software engineering is you can get involved in any field and you can apply your skills to that field because everybody needs engineered software. So it's absolutely essential that software engineers be able to work on a team, which means they have to have good communication skills. Software engineers also work not only with technical people, so other software engineers, but they also work with end users who might not be technical. So they need good communication skills. They need to be able to translate from a business requirement into a technology. They need to be able to go the other direction and be able to explain technical concepts to non-technical users. So I think being able to work as a team and also having good communication skills are absolutely essential. I think it's also important that they are able to work independently and that they are able to manage their time because software engineers often work under tight time deadlines, and so they need to be able to get their work done. And they need to be able to ask for help when they don't understand something because technology is changing all of the time. We can't all be experts in all aspects of technology. So they need to be able to ask for help and they need to be able to help others when others are in a situation where they don't understand the technologies. So if you're someone who likes to break the software, you make a really great software tester. If you like to do design, there's lots of opportunities to design either the user interfaces, the user experience, so more of a creative aspect to software engineering, or maybe it's designing the architecture or the components that make up the software. So there's lots of opportunities. If you like to write code, there's opportunities to write code. If you're someone who doesn't like to write code and you still want to be a software engineer, there's lots of opportunities to do requirements engineering, working with end users and translating those requirements into the software, or doing project management, or being that technical expert that helps business users.